Alrighty, let's look at graphs of geometric sequences. So we're going to look at the 4 different types of graphs that you get, depending on what R is. So in this first case, we've got a positive bigger than 1R, and we're going to have a look at how does that actually affect our graph. So you can see we've got Tn plus 1 equals 2 times Tn, where T1 equals 3. So the first term is 3, the second term is going to be times 2, so it's going to be 6, 12, 24, 48. Okay, so this is our first sequence we're going to look at. Now just as a reminder, whenever we're doing graphs, just remind yourself that a table of values is perfectly suitable and all you need. Let's say we're doing the first 5 ones. So we've got n and Tn, and we've got 1, 2, 3, 4, and 5, the first 5 terms. That's 3, 6, 12, 24, and 48. And now we can go through and just sketch this. Now the issue with geometric sequences is that they have this exponential look to them. What does that mean? Well, it just means that they grow really, really quickly. And so when we graph them, they're not going to look linear. They're actually going to look what's called exponential. So this is going to be an exponential shape. And when we talk about exponential growth, that's just a fancy way of talking about geometric growth. So it's going to be an exponential shape. So we're going to have 1, 2, 3, 4, 5 down on the n-axis. And then on the Tm axis, or the Tn axis, well, we need to get up to 50. So then 15, 20, 25, 30, 35, 40. Yeah, that's not big enough. So we're going to go 20. So we'll go 0, 20, 40, 60. Alrighty? And now we just got to plot our points. So 1, 3, it's going to be quite close to the ground. 1, 6, 3, 12, 4, 24, and 5, 48. And as you can see, again, it's a scatter plot, so we're not actually going to draw the dots, but you can kind of see that you get this shape happening here, and that's the exponential growth. It's a curve which curves towards the x-axis or the n-axis here. Alrighty, let's look at another example. Alrighty, so this looks like quite similar to the previous one, but this time we've got -2 instead of 2. But same game, T1 is equal to 3, T2 is equal to -2 times 3, -6, and repeat. And in fact, the only difference between this one and the one we did before is that every second term is going to be switching signs. So in this case, all the odd terms are going to be even, are all going to be positive, and all the even terms are going to be negative. It's not a hard and fast rule, it's just how this particular sequence is looking to be. And now that we've finished up our values, I'm not going to draw this one in a table of values, but just remember that the same principle can be used. But now the problem is that our x coordinates, I will do it, but remember, this is just for practice. Alrighty. So in this case, we've got a much more problematic Tn, meaning the x-axis is still going to be easy, that's just our n-axis, but our y-axis, our Tn axis, needs to go both positive and negative. In this case, it actually needs to go a lot more positive than it does negative, because the biggest positive number we have, the highest number is 48, and the smallest number we have is -24. And so we're going to get a slightly different shape on this one. So once again, we'll probably go up in tens. We've got 20, 40, and that's going to be 50 up there. And then on the negative axis, we've got 10, 20, 30. X-axis and axis quite straightforward. 1, 2, 3, 4, 5, 10, 20, 30, 40, 50, Tn, -10, -20, -30. And now we've just got to plot our points. So 1, 3, same as where it was before. 2, -6. So this time it's below the axes. 3 is 12. 4 is -24. and 5 is going to be positive 48. That's right up here. And in this case, we get this kind of two different ones zooming away from the axis is what we end up as the final picture. But it kind of looks like you get this ping-ponging effect where the bounces are getting further and further away from the n-axis. So the bounces get bigger and bigger over time. And that is a negative shape. Alrighty, let's look at another one. So let's look at this particular one. So we've got Tn plus 1 equals a half Tn, T1 equals 48. So T2 is just going to be a half times 48, which is 24. T3, a half times 24, 12, half times 12. So you can see this one is a shrinking case, right? It's slowly getting smaller and smaller as you go through. And so the shape is going to reflect that. It's going to be a decreasing one. So once again, our points, we're going to have 1, 48, 2, 24, 3, 12, 4, 6, and 5 is 3. It's kind of like the reverse of the sequences we were just looking at. But once again, quick graph, 20, 40, 50 on the x-axis, and sorry, on the y-axis, and then 1, 2, 3, 4, 5 on the n-axis, and this is our Tn axis. And so we get 20, 40, 1, 2, 3, 4, 5. So we get 148 right up here, 224, 312, 4, 6, and 5, 3. And in this case, you can see that you get this shape where it's approaching the x-axis quite quickly. Especially at the beginning, it starts really steep, and then it slowly approaches 0 as the terms get smaller and smaller. So, one more graph to have a look at, and that's what's going to happen when r, our common ratio, is actually negative and less than 1, and less than negative 1, or bigger than negative 1. Alrighty, so Tn plus 1 equals negative a half Tn, and the first term is going to be negative 48. So T2 is going to be negative a half times negative 48. Negative times negative is positive, and we get 24. T3, negative a half times 24, negative 12. T4, negative a half times negative 12, 6. And T5 is going to be negative a half times 6 equals negative 3. So this is going to be a slightly different one again. This time I'm not going to write the points, but no, my smallest number has to be negative 48, and my biggest number on my Tn axis is going to be 24, my vertical axis. So it's going to look something a bit like this. So 10, 20, 30 on the positive, negative 10, negative 20, negative 30, negative 40, negative 50 on the on the negative vertical axis. So there's n, there's Tn, 1, 2, 3, 4, 5, negative 10, negative 20. I finishing up my axes. And 0 in the middle. Alrighty, so let's plot the points in. First point, 1, negative 48. Second one, 224. 3 is negative 12. 4 is 6. And 5 is negative 3. And you can actually see that this time you get that ping-ponging effect like we saw on when we had r was equal to a half, but this time it ping-pongs towards the x-axis. So these are the different shapes that you can see, and they tell us what r is equal to. So when r is bigger than 1, this is the shape you're going to get. You're going to get this increasing shape. When r is less than -1, then you're still going to get that increasing shape, but it's going to be bouncing away. So you're going to end up with something like this. For the next one, this is what happens when r is less than 1 but bigger than 0. You get this decreasing shape happening. And when r is bigger than -1 but smaller than 0, you're going to get the shape that we see here, which is going to be ping-ponging up and down until you reach the x-axis. So these are the different shapes of geometric sequences, and there we have graphed a few. I'll see you in the next one. Goodbye.